Session 9.5, Comparing two population means. For these sessions, we do have a two-part. First part, we're going to talk about population mean for independent sample. And we will conduct hypothesis testing and construct confidence interval. For the second part, we're going to talk about the population mean for dependent samples. And also, we will conduct hypothesis testing and construct confidence interval. First, let's look at the difference between independent versus dependent samples. When comparing two populations, it is important to note whether the data are two independent samples or pair samples. Pair samples talking about the dependent samples. Now, let's look at the example for the independent samples. We have the population 1 here, sample of students who had used a computer in their math class in 2010. And then we have the population 2, sample of students who had used a computer in their math class in 2023. So you could see we do have two populations, and also these samples are independent. Those students are not related to these students here. So this is two separate independent samples. Okay, we want to know, are the population means scored differ? Now, let's look at the dependent sample. Dependent samples we also call pair samples. We collect the pulse weight of a random sample of people before the meditation. After the meditation, we collect the pulse weight of a random sample of people after the meditation. So the sample is come from the same group of the people. And then we have two samples, a sample of the pulse weight before the meditation and a sample after the meditation. And this is called the pair samples because each value in one sample can be paired with the value from the same person in other sample. And these pairs we call match pairs. So and that's why they call dependent samples, because they come from the same group of the people, and also they can call the pair samples. Okay, you guys know what is the difference between independent sample and a dependent sample, right? Each observation in one group is coupled or paired with one particular observation in other groups. Before and after comparisons. So this is talking about like here, before and after, okay? Related object, it come from the same people or same sibling or same spouse. Okay, example 1. People chosen in a random sample are asked how many minutes they spend reading and how many minutes they spend exercising during a certain day. Researchers want to know how different the mean amount of time were for each activities. Is this a dependent or independent sample? Think about it. Is it the data come from the same person? Yes, right? The samples are dependent. The study was based on one sample of people who were measured twice. Okay, one is a reading, one is for exercise. So this is called the match pairs. Let's try to do B and C by yourself. B. A sample of men and women each had their hearing test. Research want to know whether typically men and women differ in their hearing ability. Is this a dependent or an independent sample? So think about it. We have a group of men and a group of women. Okay, both groups gonna receive the hearing test, and then we're gonna compare the result. So you could see they are not related to each other. They are not come from the same sample, right? So this is gonna be independent. C. A random sample of married couples are asked how many minutes per day they spend exercising. Means were compared to see if the mean exercise times for husband and wives differ. Is this a dependent or independent sample? So the sample here is going to be dependent, right? Because each husband is paired with his wife. Okay, husband and wife is going to be a pair. So for these sessions, when you guys working on the hypothesis testing or confidence interval, first you have to know is the questions talking about the dependent sample or independent sample. Now let's look at the independent samples. We'll be working on the confidence interval. So first, you guys need to check the three conditions. Number one, random samples and independence. Both samples are randomly taken from their population and each observation is independent of any other. So first, it has to be random samples and also the sample is gonna be independent of each other. Number two, independent samples. The samples are not paired. So the samples from the population 1 and the population 2 is not paired, okay? Number three, large samples. Population are approximately normal or the sample size are each 25 or above. So here, this is talking about we have to fulfill the central limit theorem. Either original population is normally distributed or sample size is at least 25. So general structure estimated plus minus the margin of error. For these sessions, we are working on independent samples. We do have two populations. So we want to estimate of the difference. The mean of the difference with the population 1 minus the population 2 plus minus the t star. T star is talking about we'll be using the t distribution times standard error. Okay, the estimate of the difference. So this is talking about we do have a population 1, population 2. Make sure you guys state that the mean of the difference equal to mean 1 minus the mean 2. Okay, let me know which one is your population 1, which one is your population 2. And then standard error, that will be the formula. And for these sessions, I let you guys use the calculator to construct the confidence interval. Okay, so this is the formula to construct confidence interval. Sample mean 1 minus the sample mean 2, and then plus minus the t distribution times standard error. When we're using the t distribution, we do have the degree of freedom. Okay, that's from the section 9.4. Since we have two samples in here, we may have two different degree of freedoms. So if you're using the calculator, they do have a specific formula to calculate the degree of freedom. But if you guys using the t distribution table, you may want to choose the smaller of the degree of freedom. You're gonna see which one is gonna be smaller, then you're gonna use that one, okay? So if you guys using the formula with the t distribution table, the answer may be slightly different from using the calculator. Interpreting confidence interval, independent samples, mean 1 minus mean 2. So remember this part we talked about at the session 7.5 already. At that time, we're talking about the population proportion, okay? I just go for a little bit here. So if you find the difference of the population means, that is counting the 0, okay? That's maybe from negative number to positive number. So we know that the confidence interval will be counting zeros. That means the mean 1 will be equal to mean 2. If both values of the confidence interval are positive, then mean 1 is going to be greater than mean 2. and both values in the confidence interval are negative, then we know mean 1 is going to be strictly less than the mean 2. Okay, one more time. If you want to know more details about this part, you could review the video of the session 7.5. Okay, this is the instruction how you guys use your TI-84 calculator to calculate the confidence interval. I'm gonna show you guys how to do it with your calculator later on. Let's do this example together. A college randomly surveyed day students and evening students to determine the number of units students were enrolled in. The data is shown in the table below. Use the data to find a 95% confidence interval for the difference in the mean difference in number of units for the two groups. Based on your confidence interval, is there a difference in mean number of units taken by day and evening students at this college? So we do have a day students and evening students. We have the sample size, sample mean, and the sample standard deviation. So first, let's check the conditions. Number 1, random samples and independent. Number 2, samples are independent. So we do have two groups of students and they are not related to each other. Okay, samples are independent. Sample size, both of them is going to be at least 25. This is good. Okay, so either I let the day student will be my population 1, evening students will be my population 2, or I could just specific write it down here, mean of the day minus the mean of the evening. Okay, you could find the answer is gonna be looks like this guy. Okay, I'm gonna show you guys how to use the calculator, okay, after this slide. So we find it out. The difference of the population mean will be in between 1.66 and 3.94. So look at this table. Will the mean of the day students will be equal to the mean of the evening students, or strictly greater than or strictly less than? The confidence, both of the values are positive. So we're gonna know the mean of the day student will be greater than the mean of the evening students. Okay, this is from the table here. Okay, both of the values are positive, so mean of the day students will be strictly greater than the mean of the evening students. So day students enroll on the average in more units than evening students at this college. The difference in the mean number of the units enrolled is estimated in between here. Okay, right? Okay, now let me show you guys how to use your calculator. Okay, go to the stat, go to the test, and then we're gonna go to two sample. Okay, two independent sample, t-distribution, confidence interval. Enter. Okay, you could see there's a data and statistic. Statistic means they already give you the summary of the sample size, sample mean, and sample standard deviation. Sometimes they may give you the set of the data. Okay, you may need to input it in the L1 or L2 here. But right now we do have the summary statistics. So we're gonna go to here. Enter. And then we have the sample mean 1. Okay, my sample mean 1 is talking about the day here, mean of the day. So that will be 8.7. Standard deviation, sample size, then mean 2, standard deviation, and sample size. Okay, we are working on 95%, so it's gonna be 0.95. And for the pool here, you could just put no, okay? Calculate. So this is what we get. 1.66 to 3.94. Okay, they do have the degree of freedom. It's going to be 130.97. Okay, and actually you could see if you guys using the t-distribution, the table, you may want to find the degree of freedom is going to be 67. We're going to find the smaller one, 67. But when you guys use the technology like the StatCrunch or like the TI-84 calculator, they do have a complicated formula to find the degree of freedom. So if you guys using the formula and t-distribution table, you may get a little bit different from my answers here. Okay, but for the exam homework, feel free to use the TI-84 calculator. Okay, example 3. Data on the selling price in hundreds of dollars was obtained for a sample of home in New Mexico. Homes were classified as located in the northeast section of the city or in another location in the city. The data are sorted in the table below. Construct a 95% confidence interval for the difference in mean home price between the northeast section and other sections in this city. Is there a difference in home price? Okay, first, check condition. This is going to be random sample and independent. And we believe the samples are independent. And then large sample size. Okay, both sample sizes at least 25. So this is good. Okay, so I use the mean of the northeast minus the mean of the other here. Okay, use your calculator. You should get this guy. Okay, think about it. Will the mean of the northeast will be equal to or greater than or less than the mean of other? You're gonna review the table from the previous slides. Here, one negative, one positive means they contain the zero. If they contain the zeros, it means they will be equal to each other. Okay? So we're gonna say there's no significant difference. So we're gonna say there is no significant difference in the average home price between the two areas. Okay, right? So this is how you guys construct the confidence interval for the two population means. Now, we're gonna work on the hypothesis testing. So first, we're gonna state the null and alternate hypothesis. Null hypothesis, we're gonna always put in equal here. Same idea for the alternate hypothesis. It can be not equal to, strictly less than, or strictly greater than. Not equal to, there'll be two tail. Strictly less than, left tail. Strictly greater than, there'll be right tail. Okay, prepare. Random sample and independent observations. Number 2, independent samples. And also both populations are approximately normal or both sides are at least 25 or more. Okay, right? So pretty similar to the population proportion. Number 3, we're gonna find the test statistic. So that will be the formula. We'll be using the t-distribution, okay? But I let you guys use the calculator to find the test statistic. And then use your calculator to find the p-value. Compare with your significance level. If the p-value is less than or equal to the significance level, then we reject the null hypothesis. And then make sure you guys draw the conclusion. Okay, look at the step how you guys use your calculator to find the test statistic and the p-value. We do have the same example from the previous slide. That one is construct the confidence interval. This one will be working on the hypothesis testing. So first, we're gonna write down the null hypothesis. Okay, it has to be equal, right, for the null hypothesis. And then, what is the alternate hypothesis? We're talking about by the day and evening students at the college are different. Okay, are different, so that will be not equal to. and this is gonna be two-tailed test. Okay, and then check the condition. Random sample, independent observations, and then independent samples. And then both sample size are at least 25 or more. Okay, right? Now, use your calculator to find the test statistic. I'm gonna show you guys after, okay? You should find t equal to 4.84, and then you do have the p-value 0.000036. It's really small because that's a pretty large of the test statistic. And then we're gonna compare with your significance level, less than or equal to. So there'll be reject, okay? And then draw the conclusion. There is sufficient evidence to support the mean number of the units taken by the day and evening students at the college are different. So we reject the null hypothesis. So look at right here. We reject the null hypothesis. So that means the mean number of the units taken by the day students are different from the evening students. Okay, it matches with the confidence interval, right? Remember from the confidence interval? Like here, the mean number of the units enrolled in the day student is greater than the evening students. Okay, so it matches with the confidence interval as well here. Okay, now let me show you guys how to use the calculator. Follow this step here. You're gonna go to the stat, go to the test, and then we're gonna go to the two population independent sample, t-distribution, hypothesis testing. Okay, so we have the statistics summary here. We have 8.7, 3.1, 72, 5.9, 3.7, 68, and then we have a not equal to. You're gonna put no, and then you're gonna go to calculate. Okay, so you do have test statistic 4.84. And then p-value, make sure you don't write it down for your p-value like 3.607, okay? We do have the e to the power of -6 at the end. Remember, this is a scientific notation. That means it's 3.607 times 10 to the power of -6. So you're gonna get your p-value is 0.000036, which is really, really small. Okay, I want you guys try to do the example 5. Okay, check your word. Hypothesis equal, right? And then it's gonna be not equal to. Okay, it's gonna be differs from other areas of the city. So same thing, it's gonna be two-tailed. Checking your condition, random sample, independent observations, independent samples, and both sample size are at least 25. Okay, right? Use your calculator, you're gonna get t equal to -1.96 p-value. And then compare with your significance level. This is gonna be strictly greater than, okay? It's gonna be 0.052. When this is 2, this is a 0, so it's gonna be greater than. So it's gonna be fail to reject. And draw the conclusion. There is not sufficient evidence to support that. Okay, you also can compare the result with the confidence interval. So fail to reject, that means they're equal to each other, right? The null hypothesis is gonna be right. They're equal to each other. And then for the confidence interval, we find it out, confidence interval contains the 0. So we know they are equal to each other. It matches with our result. So this is good. Okay, now second part, dependent sample. Transform the original data from two variables into a single variable that contains the difference between the score in group 1 and group 2. Remember the dependent samples? The two data that's come from the same person. And then we want to find the difference between the first data and the second data. After the difference have been compiled, we can apply either a confidence interval approach or a hypothesis test approach to the difference. So we're gonna do both of them, confidence interval and also the hypothesis testing for the dependent samples. Okay, this is how you guys using the calculator. Okay, usually we'll be input the first data in L1 and then input the second data to the L2. And then for the L3, we're gonna find the difference using the calculator. Okay? Okay, let's do this example together. Suppose fourth grade children are exposed to a reading intervention program designed to improve scores on the reading assessment. Children were given a pre-test and post-test before and after the reading intervention, and the scores are shown in the table below. Assume that all conditions need to construct the confidence interval are met. Construct a 95% confidence interval for the mean difference in reading score after participating in the program. Based on your confidence interval, do you believe the reading program is effective? So we do have a two set of the data, and this is going to be the p-test score and this is the post-test score. And this score is going to be come from the same person. So we call this is the pair sample. First, we're gonna state the mean difference equal to the mean of the pre-test minus the mean of the post-test. So if I set it up like this way, the difference will be 10 minus 12 equal to negative 2. Okay, you don't have to set it up like this way. You can do another way around. You could do post minus the p-test, then this guy will be positive 2. Okay, it doesn't matter which way you set it up, but you have to stay it in here. Okay, especially on your exam, I need to see this guy. So we could do the subtraction here. Okay, we're gonna calculate 21 minus 23, we're gonna get negative 2 and so on. Okay, you could work on this part using your calculator, okay, or you could just do it by yourself in here. And then we construct 95% confidence interval. So if I'm using my calculator, I'm gonna get this guy. Okay, I'm gonna show you guys how to use the calculator after this slide. And then you could see both values are negative. Okay, this is not including the 0, so I believe they are not equal to each other. And both values are containing negative values. So there is a significant difference in the mean pre-test and the post-test score. However, the difference is not large in size. Okay, they do have a difference. They are not equal to each other. But when you guys look at the number here, it's only like between 0.19 and 2.9 points. Okay, so actually the reading intervention program, it helps a little bit. Okay, not that much. And then since the difference were for the pre-test minus the post-test, okay, pre-test minus the post-test, and then we having the negative values, means post-test scores was greater than the pre-test score. So post-test score is better than the pre-test score. So actually there was improvement after the reading intervention program. It's just not that much. Okay, now let's look at your calculator. So go to, before you guys go to the stat, go to the test, you have to input the data. So we're gonna go to the stat, go to number 1 added, okay? Let me clean it up first. Okay, So on L1, I'm gonna plug in to my p-test. L2, I'm gonna plug in the poll test. Okay, right? You could either just plug in the difference here, but I want to double check my work. So what I'm gonna do, I'm gonna go to the L3, highlight the L3, and then I'm gonna do the mean of the difference will be the p-test minus the post-test. So I'm gonna do second one for L1 minus second 2 for L2. Okay, right? And then enter. So the calculator is gonna be calculated by itself here. So you're gonna check your work -2, 0, -2, -1, -6, -4, -1, and so on. Okay, right? So this is how I get the difference in here. And then I'm gonna go to the stat, go to the test, and I'm gonna go to the t interval. T interval, okay, T distribution confidence interval. And then I do have the data this time. I don't have the statistics summary, so I choose data. And then the difference is gonna be on L3, right? So I put second 3 for L3. Frequency, I just need to put 1 here. And then I'm constructing 95% confidence interval for so 0.95 and then calculate. So this is how I get -2.9 and -1.9. Okay. Okay, after that, we're gonna perform the hypothesis testing, and this is gonna be the instruction. So we do have the same questions. This time, we're gonna be working on hypothesis testing. So first, I'm gonna state the mean of the difference equal to the mean of the pre-test minus mean of the post-test. And then, the null hypothesis. We're gonna let mean of the difference equal to 0. And then the mean of the difference not equal to 0, because they only want to see if there's a difference. Okay, that's a difference, so it's going to be not equal to. And this is going to be the two-tail. Okay, prepare. They say assume the condition for conducting hypothesis testing are met. So we don't have to state it one more time, okay? Now use your calculator. You should find your test statistic -2.54. So that's the p-value we're gonna compare with your significance level. That will be reject. Okay, reject the null hypothesis. And say there is sufficient evidence to support that there was a difference in mean p or post-test scored after the reading intervention. Okay, it matched with the confidence interval because they are not equal to each other. Okay, I want you guys to double check here. When we have an independent sample for hypothesis testing, the mean, we could just state like the mean of the northeast equal to the mean of the others, okay? But when we're working on the dependent sample, the pair sample for the hypothesis testing, we always use the mean of the difference. Okay, keep in mind when you are working on the match sample here, because we want to find the difference in here. So we always have the mean of the difference. Okay? Even though the confidence interval, we're gonna put mean of the difference instead of putting like this guy here. And then the hypothesis testing will be using the mean of the difference. We'll compare with the 0, equal to, strictly greater than, or strictly less than, or not equal to. Okay, one more time, when you have an independent sample. For the confidence interval, we're gonna stay straightforward here. Population 1, mean of the population 1 minus the mean of the population 2. Hypothesis testing, we'll be using these two kinds to compare. But for the dependent sample, okay, we need to find the difference. So the confidence interval, we only say the mean of the difference. Hypothesis testing, we'll be using the mean of the difference equal to 0 or strictly greater than, less than, or not equal to 0. Okay? That's it.